All right, ladies and gentlemen, today you are going to take some notes to put in your notebook on slope-intercept form again, which remember is y equals mx plus b. And these are going to go right in your notebook, page 58, opposite the ones we did the other day on page 57. So, the first thing you're going to notice on your sheet is you've got a line that's already been graphed for you. And the first part of doing these questions is you need to determine if the slope is positive or negative. This one is definitely going uphill from the left to the right. Slope dude would say puff puff positive. So you just need to indicate, and that's going to help you when we talk about slope to make sure you have the right value down here for slope. Before we get to slope, we are going to locate where your line crosses the y-intercept. The y-intercept, remember, is where your line crosses the y-axis. Your y-axis is always your vertical axis, and this particular line seems to be crossing down here 3 points below the origin. So our y-intercept is going to be given as -3. Now for your slope. The best way to calculate slope when you have a line graphed in front of you and there's 2 points identified is to draw a slope triangle. So remember, to draw a slope triangle, you pick the point on the left. You either rise or run to get to the next point. We have to rise in this case. And we're only going to go as high as the second point is, and then we're going to run to the right. By shading in the slope triangle, you can visualize the amount that you've gone up, the rise. In our case, we've gone up 5 boxes. And then you can see that the run is only 3 boxes. So our slope is a positive value. It's going uphill. And it is exactly 5 boxes for a rise, 3 boxes for a run. What you'll notice now is that we have all the information we need to write our equation. We have our slope of 5/3, and we have our y-intercept of -3. So to write the equation of our line, we are simply going to substitute our values for slope and y-intercept. Now, one of the things we can do with this type of equation, since our intercept is -3, we can write 5/3 x, and we can simply just say -3 to make it a little simpler. But if you want to keep it plus -3, that's fine. Both are considered correct. This one is more popular since obviously it's a little more simple. When you graph, remember that you're going to label the graph with the equation, so that should be indicated along the side of the line that we were working on. So again, there's 2 components that you need to identify, y-intercept and slope. You know how to do both, so today we're just practicing making sure we can get those values and correctly type them into our slope-intercept form of our equation. Now, for some guided practice. Your first equation is headed downhill from the left to the right, so we need to indicate that the slope is negative. Remember that our b value stands for our y-intercept, so we need to locate our y-axis, and we need to find out where our line crosses that y-axis. And it looks to me like it crosses at +4. And now for our slope. We have to indicate 2 points on the line, and this wasn't done for us. So we need to very carefully note this point can be utilized because the line crosses perfectly on the grid lines. This does not cross perfectly, so we need to continue down our line until we find one. We could use this one all the way down here, which does cross on the grid lines perfectly, but I found a closer one up here to my original point. So I am going to utilize these 2 points. Starting on the left, you're going to draw your slope triangle down for this picture, and then over, and again shade it in so we can tell. So your rise is going to be down 3 boxes. We need to use -3. Your run is +2. So just like we said earlier, our slope of our line was negative. We do have a negative value for our slope that we will now plug in to your formula. So the formula, remember, always starts out y equals. You always place your slope in the spot where the m is in the original equation, and then you always put your y-intercept at the very, very end where the b is, okay? So this is just a formula that we're substituting values in. And we know that this is always our slope. We know this is always our y-intercept. Take a second to label the line right on the equation, please. Lines should also have arrows in both directions, so if you would please correct that, and that'll be correct. Next example, we have another line that is heading downhill, so we know this is a negative slope. What's a little strange about this one is we see that our y-intercept actually crosses right here at the origin. So what that means is we have a 0 y-intercept. And then if we want to use this point, we need to locate another point which crosses perfectly. Be careful, don't pick one like that that's close. You want to pick one that's exactly crossing, like this one down here. We know for sure that that line definitely crosses through that point down there at the bottom. So your slope triangle should look like this. And when we start to look at our rise, we have 1, 2, 3, 4, 5 boxes down, so it's a -5. And we have 3 boxes to the right. So our slope is down 5 over 3, so -5/3. We're going to take our formula, that's the slope-intercept formula, and we're going to substitute in our values. And what you'll notice with this one is we have a +0 at the end because of our y-intercept of 0. In mathematics, when you go to add 0 to some known value or quantity, it doesn't change anything. So what you will typically see with this one is the fact that they will just not show that +0 y-intercept. They're just going to leave the y equals -5/3 x. This is mathematically correct, but this one you'll see more often than not when there's a 0 y-intercept. Now, for the bottom 2 examples, you will see a positive slope on both. They are both heading uphill from the left to the right. They look very similar, but I want you to keep in mind there are 2 components that make up the equation of the line, and they're very important components to notice. This one has a y-intercept at +2. This one crosses the y-axis a little bit higher up. So we need to make sure we indicate that by making sure we indicate that it crosses at +3. And then we have to do our slope triangles. Your slope triangles, remember, are going to tell us the steepness of your lines. So again, these equations do not have points plotted for us, so we need to indicate 2 points where we know exactly cross. And it looks like right here it crosses, and right here it crosses. So your slope triangle is going to be very small. It's going to show a positive rise of 3 and a run of 1. Please remember, if your fraction can be reduced, you should reduce it. So now when we write our equation, y equals slope of 3, then we have x plus 2. For this example, remember we're going to use the point that we already located on the y-axis, and then we're going to continue until we find a point that crosses perfectly, and we do not get a perfect intersection with the little grid lines until way down here. So please draw your slope triangle. And notice we've got 1, 2, 3, 4, 5 for our rise. We've got 1, 2, 3 for a run. 5/3 does not reduce, so you can go right into your slope-intercept formula. You can plug in your slope, and you can plug in your y-intercept. Now, there are more equations on the back for you to practice. I'd like you to pause the video at this point, try them on your own, and then when you are finished, play the video to check your answers. Then we'll tape it into our book. Okay, to check our answers on the back of your note sheet, your first example is straight across. So that tells us that our slope between any 2 points is going to be 0. And we notice that the y-intercept is down here at -1. So when we have those 2 components, remember, you're just going to plug it into the formula. The thing with 0 in this case, being that 0 is your slope, 0 times x is really going to have a value of 0. 0 minus 1 is -1. So typically this type of line you're going to see called y equals -1. You're not going to see it reported as y equals 0x minus 1. You're going to see y equals -1. For this example over here, we have our y-intercept right here at +2. We have our slope triangle showing a +1 rise and a +2 run. So there's your slope, y equals 1/2 x, and our y-intercept +2 for that equation. Now, continuing on, you had 2 more examples on the bottom. This one shows a y-intercept at 4. And it shows a slope triangle of 1, 2, 3 over 1. Remember, we can take our slope and reduce it when possible. So that's why we have our equation y equals 3x plus 4. And for the last one, we have a y-intercept at 0. And we have our slope that is only down one little box to the right 3. So -1/3 for our slope. This goes in y equals -1/3 x plus 0. But remember, adding 0 to this whole quantity doesn't change it, so you're typically going to see the equation written as y equals -1/3 x. At this time, what you're going to do is you're going to open your notebook. We already taped in page 57 the other day. And remember, with a full-size worksheet like this, you want the page to be able to open up all the way. We're going to do the same thing with this side. So when you fold it in half, you want that first example that we did to show first. And if you can see, I don't know if it's very clear, but I have just 3 small pieces of tape on this side of the book. And that's going to allow the page to open up. And you'll be able to see all those examples we just did. You'll be able to open it up so that you can see all the examples that we did first. And then it's attached in the center of the booklet. And then when you fold it flat, it will stay in your book nice and neat.